Okay. So apart from the incenter and the circumcenter, right? There are two more important centers um, that are important as far as triangles are concerned. So one of them is called the uh, point of intersection of the medians. Right? Point of intersection of the medians. And the other one is the point of intersection of the perpendiculars. Right?
Yes, sir.
So uh, if suppose D is my midpoint of BC, right? The line that joins A and D will be the median of one of the medians of
ABC.
triangle.
Hmm.
Similarly, if E is my point of midpoint of AC, this is another median, right?
Mhm.
And this would be my third one, right?
Right.
So uh, the point that is the intersection of all of them is called the centroid.
Okay.
Okay,
Yes, sir.
this is called the centroid. And how do we find out the centroid?
If we find two of them where they intersect.
Sorry, come again. Vishal, can you
Where two
repeat
of
that?
them, yes, it's where two of them intersect.
Yes, correct. And how do we find this out? Suppose we are given the sides A, B, and C. How do we find out the centroid?
Um, it is the midpoint of one connected to the end point of another.
Absolutely correct. So this would be, each one would be half of the respective sides, right?
Yes.
Right.
Right.
So in uh, in case of triangle ABD, right, is AB is equal to C and BD is equal to A by 2, right? And we know angle B, right? We know angle B, right?
Yeah.
So therefore, we can find out the length of AD. Can we do it?
Yeah.
Yes, sir.
We find out the length of AD, right? And similarly, we can find out the length of BE as well as CF using the other triangles, right?
Yes, sir.
And So this is how you can find out the length of each of the medians. And in order to find the point of intersection, we just need to have the equation for any two of them. And if we know the equation of any two, then we can solve to find the coordinates of G, right? Right?
Yes,
Right.
sir.
So how do we find the equation of any two? Now this is where coordinate geometry comes in. So if this is x1, y1, this is x2, y2, and this is x3, y3, what will be the coordinates of D?
It would be um, one x
1x2.
Yeah, tell me.
1x2. No, 1x.
Midpoint is simple, right? In
right.
general, it is mx2 plus nx3 by m plus n. But if m and n are equal, that means if this is a midpoint, then it's directly x2 plus x3 by 2.
Okay.
Correct?
Yeah.
Yes, sir.
Similarly, y2 plus y3 by 2. Right?
Yeah.
And A is x1, y1. Right? So we know the 2 points A and B. So we can find out the equation of the straight line passing through these points. Correct?
Yes.
If I call this as y4 and this as x4, then AD, equation of AD, or rather the slope of AD would be y4 minus y1 by x4 minus x1, right? Are
Right.
you able to follow this?
Yes.
Sure.
Yes, sir.
So this is the this is a slope of this line. So therefore the equation will be y equal to y4 minus y1 by x4 minus x1, which is the slope, into x plus c, right? And you can put in the value of either x1 y1 or x4 y4 in this two to find out the value of c, because it passes through both points. Clear?
Yes.
Yes, sir.
This is one way of doing it. The other way of doing it is, if I assume this as x and y, then I can do it directly. So since G is a point on AD, so therefore the slope of GD and AD will be the same. So y minus y1 by x minus x1 will be equal to y4 minus y1 by x4 minus x1. This will give you the equation directly,
Yes, sir.
right?
Right.
So similarly, you can find out BE. You don't need to do all three, just need two of them, and you can find the point of intersection. So you can find out BE similarly, right? So E would be x1 plus x3 by 2, y1 plus y3 by 2, and similarly you can find BE. BE. Sorry, B is x2, y2. So the slope of BE would be, if I call this x5, y5, so this would be y5 minus y2 by x5 minus x2, right? And that would be equal to x minus y minus y2 by x minus x2. Correct?
Yes.
Yes, sir.
Kushal, you are able to follow this?
Yes.
So you can find out the equation of AD and BE, okay? And you will get the equations in terms of y equal to m1x plus c1 and y equal to m2x plus c2. If you solve these two equations, simplify these two equations, not solve. And then you can solve for these two, you will find the value of x and y. Correct?
Yes.
Yes, sir.
So we will do a problem with numbers so that this becomes clear. Okay? So this is where the importance of coordinate geometry comes in, because uh, when we are defining any geometrical figure, right, we need to define all the important points in that figure, right? So centroid is one such point, okay? And we'll do a couple of examples with numbers on this, right?
Yes, sir.
Okay. Before that, I just want to touch upon the last important uh, property, which is the point of intersection of the perpendiculars. So this is one of my perpendicular. This is my second perpendicular, and this would be my third one, right?
Right.
Yes, sir.
And this point is called the orthocenter. Orthocenter, which is point of intersection of the perpendiculars from each vertex to their opposite sides, right?
Right.
This is the meaning of orthocenter. Okay.
Okay.
Yes, sir.
And how would we find the orthocenter? For that, we will have to cover one more topic on coordinate before we can do this. Okay, so I will do that and then I'll come back to this. Okay,
Yes, sir.
okay. Now tell me, from what we have discussed, between the four important points, which are number one is the incenter, number two is the circumcenter, number three is the centroid, And number 4 is the orthocenter. Okay, tell me from what we have discussed, where will these points lie? Will all of them lie inside the circle, outside the circle? How will they lie?
Orthocenter has to be inside.
Which one?
Orthocenter and centroid have to be inside.
Orthocenter, centroid. These two.
Yes.
Okay, let's look
Um,
at what are the possibilities. If I have a triangle like this, then my perpendicular would be like this, right?
oh, yes.
And this one would be like this. So where will it lie?
It would lie outside to the bottom left.
It would be outside. It would be outside. Correct?
Yes,
Yes.
sir.
Right? And the third one would be something like this. So orthocenter can lie inside or outside. Can it lie on one of the sides? Can the orthocenter lie on one side?
Yes.
When?
When it is a right triangle.
Absolutely. When it is a right angle triangle, what is happening?
This side itself is a perpendicular to the other
Exactly.
side.
So this one becomes the perpendicular. This one becomes the perpendicular. And the third perpendicular would be like this. So this point becomes my orthocenter. Right?
Yes, sir.
Right.
So orthocenter can lie inside or outside or on the vertex. Right? This is a special case in case of right angle triangle. Okay?
Yes, sir.
What about centroid? What can happen in case of centroid?
Inside the circle. Inside the triangle.
Centroid will always be inside, right? No matter what. This is always inside. Correct?
Yes, sir.
What about incenter and circumcenter?
Incenter has to be inside because the circle is inside the entire circle,
Very
or
good.
inside the entire triangle.
This is inside. What about circumcenter?
That can be outside.
Might be outside. Correct. When will it be outside?
Obtuse triangles.
Exactly. Right? So circumcenter can be outside in case where the triangle is like this. Right? And by definition, when we talk about incenter, what is the property of an incenter?
It is the circle is inside the triangle.
Circle is inside And also there is one more important property. By definition, when we are constructing an incenter, right? When we are constructing an incenter, this circle, this circle will divide the angle into two equal parts, right?
Yes, sir.
The circle, the incenter will divide each of the angles into two equal parts, correct?
Yeah.
Yes, sir.
Similarly, the circumcenter divides what?
It divides the sides.
We saw that yesterday, right?
Yes.
So this divides the sides into two equal parts. So this is incenter is the angle bisector and circumcenter is the side bisector, right?
Right.
Yes, sir.
So in case of incenter, as you correctly said, because the circle is inside, so it has to be inside. However, in case of circumcenter, the circumcenter can lie outside if it is a obtuse angle triangle. So in that case, the side bisectors can be like this, right? So it can lie somewhere here, right?
Right.
Can lie outside the. Can it lie on any side in circumcenter? Can it lie on one of the sides? Can the circumcenter lie on one of the sides?
The circumcenter. No.
What happens if when this is a right angle triangle?
Oh, right. Yes, because then its 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 side would be the hypotenuse would be the diameter. So its center.
Exactly. If it is a right angle triangle, then it will lie on the hypotenuse.
Yes.
Right? Because
Right.
in a circle, the diameter always makes an angle of 90 degree with any point on the circumference. Right?
Yes, sir.
So if it is a right angle triangle, then this becomes my circumcenter. Is it clear?
Yeah.
Yes, sir.
So therefore, the incenter and the centroid has to lie inside, right? And circumcenter and orthocenter can lie inside, outside, or either on one of the vertex or on the hypotenuse. Clear?
Yes, sir.
Okay. Now when we go back to coordinate again, we will see how we can find out the coordinates of each one of these. Median I showed you, but we'll talk about the other three as well. Okay. So, okay, one more thing. All these points, incenter, circumcenter, centroid, and orthocenter, lie on the same straight line. Okay. These 4 points in any triangle will lie on the same straight line.
Euler's segment, right?
Sorry?
I think it's called Euler's segment.
Yeah, sure.
Hello?
Hello.
Yeah. Kushal, are you back?
I've always been here.
Oh, okay. I thought you
Uh,
wanted some time. Okay. So, these 4 points lie on the same straight line, right?
right?
This is a very important property of all triangles, right? Now, can these points be, can these points coincide? All 4.
Yes. In
Can,
an
can they
S-
coincide?
in a in an equilateral triangle.
Yes. In case of equilateral triangle, all 4 points are the same. Another important property, right?
Yes, sir.
Now let us see, in case of equilateral triangle, how can we find out uh, these points? So if I have an equilateral triangle ABC, and if this is my orthocenter, circumcenter, all of that, right?
Yes, sir.
How can I find out this point O? So in case of this triangle, if I extend AO to meet BC at D, right? What happens?
Right. It creates two right triangles that are
AD is perpendicular to BC. Why?
because it's the ortho center. That is the property of the ortho center.
So all these sides are equal, right?
Right.
And the angles are equal. So each of these angles are equal, right?
Right.
Each of these angles are equal, correct?
Yeah.
Yes, sir.
Now, therefore, each is 30 degree each, right? So now you can see in triangle ABD, we have angle BAD is 30 and angle ABD is 60. Therefore, angle ADB has to be 90,
Right.
correct?
Yes, sir.
So therefore, uh, the median, which is AD, becomes the
Perpendicular.
perpendicular also, which means that will be the orthocenter as well, right? And
Right.
Yes.
and since it is the bisector of the angles, so therefore it becomes the bisector of angles is what?
Centroid. Or
Incentric,
sorry,
right?
no. Incentric.
In
Correct?
Yes.
And since it is bisecting the sides also, because AD is the median, so therefore it becomes a circumcenter as well, right?
yes, sir.
So now, how do we find the length AO, OD, and AD? Length of the median, the in radius, and the circumradius. AO is the circumradius, OD is the in radius, and AD is the median. So how do we find out the lengths? How will we find out the lengths? First, we will find out AD, right? How can we find out the length of AD? How do we find out AD? Look at
So,
triangle ABC, right angle triangle, right?
yes.
Correct?
Yes.
So how do we find out AD from there?
So, AD would have to be CD squared minus,
right?
right, yes,
Right? X square minus x square by 4. That is 3 by 4 x square. So AD is root 3 by 2 x.
Yes, sir.
AD is root 3 by 2 x. Right?
yes.
And how much is OD? How can we find out OD?
We can find OD. It would be 1/2 AD.
No. Look at triangle BOD, where OD is
Right.
one of the sides, right?
Right.
How can we find out OD from there?
The same way we found AD, so it would be
Yeah,
uh,
we found AD.
OD squared equals BO squared minus BD squared.
But we don't know BO.
Um, right. Okay.
Okay. In triangle BOD, tan of angle OBD can be written as OD by BD. Can I do this?
Yeah.
What is the measure of angle OBD?
The measure, it would be 60 degrees.
OBD,
30.
30. So tan of 30 degree is equal to OD over, what is BD?
X by 2.
Right? What is tan 30?
Tan of 30.
1 by root 3.
Okay.
Okay.
Okay. Let me also tell you this here. So how do you remember the angles? Okay, there are some very common angles that you can uh, easily find out. Okay, so sine, cos, tan. Okay, so 0 degree means sine of 0 is 0. Okay, 30 degree means sine of 30 is half. 45 means this is 1 by root 2. 60 means this is root 3 by 2. And 90 means this is 1. Now the simple way of remembering this is, when you're going from 0 to 30, just add 1/4 and take the square root. Okay, so if I add 1/4 to 0, it becomes 1/4, and when I take the square root, it becomes half, right?
Yes,
Right.
sir.
Again add 1/4. So half plus 1/4 is what? Sorry, not half plus
The
1/4. 1/4 plus 1/4 is half,
one
right?
half. Right.
1/4 plus 1/4 is half, right?
Yes,
Right.
sir.
Take the square root. That becomes 45. Half plus 1/4 is 3/4, right?
Right.
Half plus 1/4 is 3/4. Take the
Yes,
square root.
sir.
Okay.
Take the square root. That gives you 60. 3/4 plus 1/4 is 1, right? Take the square
Yes,
root.
sir.
That gives you 1. Just keep adding 1/4 and take the square root. This is the sign rule. Remembering the sign values, right? Now, once we know the sign values, can we find out the cos ones?
Yes, because it's 1 minus those.
So 90 minus that. That means whatever is the value of sine 0 will be the value of cos 90. It is the reverse way. So cos of 60 will be half, cos 45 would be 1 by root 2, cos 30 would be root 3 by 2, cos 0 would be 1. This is this way, this is this way, right?
Yes,
Right.
sir.
And tan is just sine by cos, right? So this is 0, this is 1 by root 3. Oops. So this would be 0, this would be 1 by root 3, this would be 1, this would be root 3, and this would be what? What would be 90?
2.
Infinity.
Oh, okay, because it's
1 by
opposite
0,
over.
right?
Yes, sir.
So this is how you remember the sine, cos, and tan table. You just need to remember sine. You don't even have to remember, you just have to understand the rule. So you keep adding 1/4 and take the square root. So that's how you can generate all these numbers. And once you generate the sine one, just do the cos from the reverse side, same in the same order, and then take the ratios which will give you tan. Okay.
Yes, sir.
So tan is tan 30 is 1 by root 3. So now we can write this as 1 by root 3 is equal to OD by x by 2. So therefore OD is equal to x by 2 root 3. Correct?
Yes, sir.
Yes.
X by 2 root 3. Right? And we had found that AD is root 3 by 2 x. Correct?
Yeah.
So what is AO?
It would be 3 square root 3 over x over 2 times 3 minus x.
So we can write OD as root 3x by 2 root 3 into root 3. I just multiply the numerator and denominator by root 3.
Yes, sir.
So that means root 3x by 6. right?
Right.
So AD is root 3 by 2x, OD is root 3 by 6x, right?
Right.
Yes, sir.
So this
But
is
if
root
you
3x into half minus 1/6, right?
right,
That is root 3x by 6 into 3 minus 1, right? Correct?
Yes,
yes,
sir.
So this is root 3x by 3 or x by root 3. Okay.
okay,
Yes, sir.
So this is how you can find out each of the values of the circumcenter, the incenter, and the centroid. Sorry, not centroid, and the median. Okay, and the perpendicular from the vertex to the opposite side in case of an equilateral triangle. Correct?
Yes, sir.
yes,
Kushal, is it okay?
yes,
Okay. Now, uh, in case of equilateral triangle, what is the area if the side is A?
Root 3 upon 4a square.
Root 3 by 4 A square. Correct. So how did we get it? So if this is my perpendicular, then AD we just found out is root 3
Is
by
root
2
3 upon 2a.
A, and area is half A into root 3 by 2 A. Half of the base, which is BC, into the height. Okay,
right,
Yes, sir.
clear?
yes,
Okay. Now let us see how we can find out the coordinates now of each of these points. So we have the same triangle ABC where this is x1, y1, x2, y2, and x3, y3. And suppose, okay, sorry, before I do this, I have to cover an important thing here, which I have not. Okay, so let us say we have a line um, like this. What is the equation of this straight line? Y equal to mx plus c, right?
Yes, sir.
Y equal to mx plus c. Is m positive or negative?
positive,
Positive. So why is m positive?
not always,
Because if you go from this point, for every unit that you go in the x direction, you have a positive value of y. Correct?
yes,
You have a positive value of y. But if the line is like this, then if you go from this point in the x direction, y decreases. So the value of y is negative. Are you getting this? Let's say the
Yes.
value of y is 1 here. You go 1 unit along the x-axis, right? And you reach a point which is higher than 1 for y, right? This is greater than 1. Correct?
Yes,
Right.
sir.
So therefore, the value of y increases as you go in the positive direction of x. So that's why this is positive. And here, as you go along the positive direction of x-axis, the value of y decreases, right?
Right.
Another way of looking at this is, if I have the curve, the first line like this, okay? So the slope of this line is the y value upon the x value, right?
Right.
Yes, sir.
So y value is this. So which is, let's say this is 1 and 5. Sorry, this is 1 and 1, and this is 1 and 5, right? And this is 0 and 1, right? So slope would be 5 minus 1 by 1 minus 0, right? 5 minus 1, that is this, 4, right? And 1 minus 0, right? Which is 1. Correct?
Yes.
Yes.
So this is how you find out the slope. And as you can see, this also means that this is the tan of this angle, right?
Right.
If this angle is x, or let's not call it x, theta, so tan of theta is equal to 4 by 1, correct?
Yes.
Opposite by adjacent,
Right.
right?
Yep. Yes.
Trisha,
Yes, sir.
you're getting it?
Yes, sir.
Okay. So this is the definition of the slope of any straight line, right? Now, if I have the line in the reverse direction, let's say I have my line like this, then if this point is 0 minus 1, and let's say this point is minus 1 and minus 5, right? And this point is, I'm sorry, this is not minus 1, this is plus 1 and minus 5, and this is 1 and minus 1, right? So here, how do I find the slope?
It would be uh -5 plus 1 over 1 minus 0.
Slope is this one, right? So what is this one? It is minus 1
-5.
minus of minus 5, right?
Yes, sir.
And divided by 1 minus 0. Right?
Yes.
Yes.
Is it correct?
Yes. No.
Is it correct?
It would be 0 minus 1.
Exactly. Exactly. Why is it 0 minus 1?
Because it has to be x1 minus y1, x1 minus y, or y1 minus y2,
Yeah,
x1 minus y2.
yeah, exactly. So this is this is 1 and minus 5. So I have taken this value first. I have taken minus 1 first, right? So I have taken this value first, minus 1 minus of minus 5. So I have to take the corresponding value here. So it would be 0 minus 1, not 1 minus 0, right? So this is
Yes, sir.
4 by minus 1 or minus 4, right?
Right.
And if I do it in terms of the angle, if I do this in terms of the angle, then what happens? So in this case, the angle is an obtuse angle, right? Always take the
Yeah.
angle from the positive direction of x-axis. Okay?
Okay.
Yes, sir.
So this is an obtuse angle, right? So,
Yes.
so the value of m or slope would be this by this, okay? But with a negative sign, because tan of any angle which is obtuse is negative. Okay, we will come to this when we go into your trigonometry to show you why tan is negative in case of obtuse angle. Okay, but tan of any
Yes.
obtuse angle is negative. Okay,
Yes, sir.
Okay.
so in this case it would be slope would be negative. Okay, now let's say I have both the lines together. Okay, the equation of the first line is y equal to m1x plus c1, and the equation of the second line is y is equal to m2x plus c2. Okay, okay.
Okay.
Yes, sir.
So the product of the slopes of these two lines is m1 into m2. Okay, product of the
Okay.
slopes is of these two lines is m1 into m2, correct?
Oh,
Yes.
Right.
yes, sir.
Now what does this mean? Suppose this angle is x, and or let me call it theta, because otherwise you'll get confused. If this angle is or let's do it in terms of alpha and beta. This is alpha, and this one is beta. Okay, if this is alpha and this is beta, then what is this angle? What is the value of this angle?
It would be beta minus alpha.
180.
What? 180 minus
alpha plus
Minus.
beta.
minus
Alpha plus beta.
Correct?
Yes.
Correct?
Yes, sir.
Yes.
So that means if I know the slope of one line, let's say I know the slope of m1, okay, which means I know the angle alpha, which is m1 is tan alpha, sorry, minus tan alpha, not tan alpha, it's negative, right? M1 is
Yes,
minus tan
sir.
alpha, right? I know this. Can I find out the slope of the other line? If I know beta, right?
Yes, sir.
If I know beta, I can find out the slope of the other line, right?
Yes, sir.
Yeah.
Kushal, are you able to follow?
Yes.
So I have to know this angle beta if I have to find out the slope of the second line, right?
Yeah.
Correct?
Yes.
Yes, sir.
Okay. So in the special case where these two lines are perpendicular to each other, if these two lines are perpendicular to each other, that means one is like this, the other one is like this, okay? So in that case, if this if this angle is 150 degree, what would be this angle? What is this angle?
It would be um
30.
30,
30.
right? And what would be this angle?
That
60.
would be
60. So that means if you are told that there are two lines L1 and L2 which are perpendicular, L1 is perpendicular to L2 and the slope of the line L1 is minus tan 30, which means minus 1 by root 3. What is the slope of L2? It's actually the other way around.
it would be
This is L1.
positive root 3.
What would be the slope of L2?
It would be positive root 3.
Sorry?
Positive root 3?
Root 3.
Yes.
How did you get it?
With perpendicular lines, it is the opposite reciprocal.
Right. I mean, from the diagram, it is clear that this is minus tan 30 and this is tan 60. Right? And tan 60 is
Yeah.
root 3. Right?
Right.
Yes, sir.
So, that means the product of the slopes, if the lines are perpendicular, the product of the slopes m1, m2 is minus 1. If the lines are perpendicular, then the product of their slopes is minus 1. Okay,
Yes, sir.
the product of their slopes is minus 1, right?
Okay. Yes.
So this is a very important property which we will be using in case of perpendicular lines, right? And if the lines are parallel, then M1 is equal to M2. Slopes are always equal. If I have a parallel line like this, then slope of L2 and L3 are equal, right?
Right.
Yes, sir.
So this is a very important property which we will use when we are dealing with lines.
Yes, sir.
Okay.
Is this part clear to you,
Yes.
Prisha?
Yes,
Is it
sir.
clear? Is this clear?
Yes.
Yes, sir.
Okay, fine. So we stop here for today. We will continue with the triangles tomorrow to find out their coordinates for incenter and circumcenter and the other
Okay.
Okay, sir.
using coordinates. Okay.
What time are we gonna do tomorrow?
Would same time work for you,
Same time? Okay.
Prisha?
So I have a few tests tomorrow.
Okay. So
I
then shall we skip tomorrow and take it on Sunday? Take it on Monday?
if you could do that, that would be nice.
Yeah, that's fine. No issues. It's up to the three of us. Okay. So we will have to adjust to uh, our timing and schedule. That's it.
Yes, sir.
Okay. So
Okay.
fine.
Yeah.
So let's meet up for Monday then, same time.
Sure.
Okay, sir.
Okay. And I'll try and roll out a small exercise for you by then.
Okay.
Okay. Did you have
Okay,
a
sir.
chance to complete the exercise earlier one?
I'm halfway done
Yes,
with that.
I'm done with that, but I had